Let's find the solution of this given differential equation, and this is actually a separable differential equation in terms that we can separate the variables on either sides of the equation. We can do that, or we can show that in this manner. You have d of y, or the first order derivative of y in terms of x, or with respect to x, plus 2xy squared equal to 0. You can actually move this term on the other side. D of y, or dy over dx is equal to negative 2xy squared. Let's say that our left hand side will be for y and the right hand side will be for x. In short, we can multiply both sides by d of x, so this would be cancelled here. But take note, do the same thing on the other side. And since the right hand side has y squared and we would like y on the left hand side, let's also divide here with y squared, so that would be removed. Do the same thing on the other side. Hence, the other form of our given equation showing that its separability is d of y, or dy over y squared is equal to minus 2x dx. Okay, so clearly it's a separable differential equation. To solve or to show for the solution, we are going to integrate both sides. The integral of dy over y squared is equal to the integral of negative 2x dx here. Okay, next is we can rewrite this in this manner. You have the integral of y to the power of negative 2 dy using the reverse of the law of negative exponent. Since we have a y squared that can be found on the denominator of a rational expression, we can bring that exponentiation up, but our exponent will become, or the sign of our exponent will be its opposite. So from positive 2, that's why we have minus 2. On the other side, just simply as it is, like that. Okay, so the the integral rather of these expressions, so we have y to the power of negative 1 over negative 1, because that's plus 1 over the sum, and then is equal to minus 2x squared over 2, and of course plus c somewhere here. So now you will have here a negative of y to the power of negative 1 equal to negative x squared plus c. Since we have an exponent here of negative 1, we can bring that down. So we have y to the power of 1, or simply y, is equal to negative x squared plus c. We don't like to see negatives because what we would like to solve is for y. We can multiply all terms by negative, and you will have here positive 1 over y is equal to positive x squared minus c. Now, there are some resources will still use plus c because c is an arbitrary constant, and even if it's already transformed as negative, since we don't know what the value of c is, so we'll have positive. But there are also instances where we will be asked to solve for c for a specific solution, so it would be better if we have something like that. Take note that our goal is y, not 1 over y. So we are going to take the reciprocal of both sides. Y is equal to 1 over x squared minus c. This is the solution of the given differential equation. We started with the separability of our equation, then we reach this expression. Again, if there are claims or given that we can allow or we can solve for c, let's solve for c and substitute that here. But since in this example there's no given, let's just stick with this answer. Okay? Thank you very much for watching.